Hey there coder, welcome back to the channel. Today we are tackling a fascinating problem from algorithm design, a problem that will sharpen your skill in dynamic programming and greedy algorithms. We'll walk through this challenge step by step, including code examples in C#, along with some personal insights and strategies I have developed over the years. The problem is pretty straightforward. We are given an array of integer called nums. Each element num I tells us the maximum number of steps we can jump forward from index I. Our goal to find the maximum number of jumps required to reach the last index in an array. And don't worry, the problem guarantees that it's always possible to reach the last index. I remember the first time I came across a problem like this, it was during one of those late night coding sessions where I have been stuck for hours trying to balance between optimizing time complexity and understanding the nature of the greedy approach. This type of problem forces you to think ahead while maintaining your position at each step, just like chess. Let me walk through a scenario. Imagine you are playing a board game. Each tile you land on tells you how many spaces you can move forward. Some tiles let you jump farther, while others barely give you any room. Your job is to strategize the fewest number of jumps to get to the end. Let's look at an example. Input nums equal to 2, 3, 1, 1, 4. You can jump one step from index 0 and to index 1 and then 3 steps from index 1 to the last index. So it only takes 2 jumps. That's the result we want. How to get there in the fewest jumps possible. Alright, let's dive into C# code. Here's the solution to find the minimum jumps. Let's break down this code line by line. Int n equal to nums.length. We start by getting the length of the array nums. This tells us how many elements we are working with. We initialize 3 variables: jumps to keep track of how many jumps we have made, farthest to store the farthest index we can reach at any point, current end to track the end of the target range of jumps. We loop through the array, but we stop one step short of the last index, n minus 1. The idea is that we don't need to jump if we have already reached the last index. Here we calculate the farthest point we can reach from index I. We update the farthest to hold the maximum of its current value and I plus num I, which is the farthest index we can jump to from the position. If I equal to current end, this condition checks if we have reached the farthest point for the current jump. If I equals current end, it means we need to make another jump. Jump plus plus. Each time we reach the end of our current range, we increment the jump counter because we are making another jump. We then update current end to the farthest point we can reach, setting the range of our next jump. Finally, once the loop completes, we return the total number of jumps. When I first implemented this solution, I tried a different strategy. My initial approach involved backtracking, and even recursion. But they quickly hit performance bottleneck. That's where the greedy algorithm shines. It helps you avoid overthinking by always making the most immediate optimal decision. In this case, we are always looking to see how far we can go with each jump and recalibrating from there. The trick lies in keeping track of the current end and farthest index to ensure we are minimizing the total jumps. You can see how the algorithm processes each jump. From index 0, we jump to index 1 because num0 equals to 2, allows us to jump up to 2 steps ahead. From index 1, we can jump all the way to the end of the array since num1 equals to 3, gives us plenty of forward momentum. And that's it. We now have a solid understanding of how to approach the minimum jump problem using the greedy algorithm. It's a powerful technique that you can apply to many optimization challenges. I hope this explanation has helped you not only understanding the logic, but also gain some intuition about problem solving in programming. If you have found this video helpful, don't forget to like, subscribe, and drop a comment below with any questions. Until next time, happy coding.